Okay, so notes number 2, pH. The definition of a pH is going to be a scale that shows a relative comparison of hydronium ions to hydroxide ions. Okay? And our formula is going to be the negative log of the hydronium concentration. Okay, understand that hydronium is the same as hydroxide. Okay, so let's look at what we're talking about here. What is a hydronium ion? Remember, concentration or molarity is in brackets. Okay, so let's look and see that water decomposes into H plus OH minus. But sometimes it goes back and forth as well until there's an equilibrium established. Every so often, this water will protonate that water and it'll become H3O. So, when we have these, how often this occurs determines the pH scale. This is how they determine the pH scale. So, when it happens 1 out of every 1 time, that's a pH of 0. When it happens 1 out of every 10 times, that's a pH of 1, 100 times a pH of 2, 1,000 times a pH of 3, 10,000 times a pH of 4, 100,000 times a pH of 5, 1 million a pH of 6, and if you notice, it's all based on zeros. 1, 2, 3, 4, 5, 6, pH of 7, pH of 8, pH of 9, pH of 10, pH of 11, pH of 12, and 100 trillion times pH of 14. So not 14 times, I'm sorry. 1 out of every 100 trillion water molecules is a pH of 14. So you can see that the acidic has more hydronium ions than hydroxide ions. And the basic, or alkaline, is going to have less hydroxide ion concentration. And so neutral is going to be, which is water, because we're getting a hydrogen here, and then the hydroxide from here, HOH, which is water. So this is a pH of 7, where we have equal hydronium to hydroxide ion concentration. So this hydrogen comes from here, and the hydroxide comes from here. Okay, so about a 3, sometimes 3.5. I'm not going to count off if you put 3.5. This is a strong acid. Here we have a greater hydronium concentration. Then all of this is going to be a weak acid. Then we have neutral, a weak base. Then between 10.5 and 11, it depends on who you're talking to. There's no exact. It's a strong base. Okay, so we have more hydroxides. Here this is going to be even. So notice that each pH value increases or decreases by a factor of a 0, 10, right? 1, 0, 1, 0. pH of 8 is going to be a weak base. pH of 3 is a strong acid. pH of 6.5 is a weak acid. pH of 11.5 is a strong base. So this pH of 3 will have the highest hydronium concentration, and the lowest will be 11.5. So which of the following is the strongest base? 13 is the strongest base. 13 minus 10 is 3, so 3 zeros, 1,000 times. Or you can put a 1 here, 10, 10, and 10, which is the same. Okay, so now to calculate pH and the hydronium concentration, we're going to use our calculators. Okay, the way to do this is you're going to type in the negative control log. You're going to, so let's do it together. Negative control log. And since it's 10 base, we don't have to put anything in there. We'll just put it here. So our first one is 0.0688. And you hit enter. So our pH is 1.16. And this is, 1.16. And this is considered to be a strong acid because it's so low. Okay, so let's do it again. Negative, the negative log of, we do the arrow, of 2.89 e to the minus 10th. So notice how much smaller this number is than this, because this would be 6.89 times 10 to the minus 2nd. So this is going to have way less hydronium, so we should get a higher pH, which is what we do, 9.54. And this is called a weak base. Okay? There's plenty of practice problems with our worksheet. So to calculate the pH from the OH, first find the POH and then subtract from 14. Remember that pH does not equal POH, but the pH plus POH equals 14, right? Because it's a relative comparison of the hydrogens to the hydroxides. So we're going to find the concentration of the POH. So let's write over here, the POH is equal to what? So let's do it. We have the negative log of 7.15 E to the negative 12. So we don't have very many hydroxides, so that's going to tell me it's going to be a low pH. And we hit enter. And we get 1.1 times 10 to the first, so 11. And we're going to subtract 14, take the absolute value of 2.85. So this is 2.85, and it is considered to be a strong acid. So our POH was 11.15. So we're going to subtract 14 from that, or subtract from 14. So then we're going to do the same thing for this one. The negative log of 3.47, I do that every time, 3.47 E to the negative third. So this has lots of hydroxides. And we're going to hit enter. So my POH is my POH equals 2.46. And we're going to subtract 14, take the absolute value, and we get 11.54. So my pH is 11.54, which is a strong base. Now, okay, sorry, I wrote over something. So let me start over. The steps to calculate the hydronium from the pH. We're going to put the value for pH into the pH formula. Remember that pH formula is pH equals the negative log of the hydronium concentration. But I can't use a negative number, so I'm going to subtract the number from the highest whole number. Okay, so 9 minus 8.23, this is my pH, and I get 0.77. This is going to be my exponent. Then I'm going to take the inverse log. The inverse log is on this button. It's the 10 to the x button. Okay, it's the 10 to the x button. So inverse log is the 10 to the x button. Okay, and we get 5.89 times 10, so you get 5.89. Let's do this. Okay, so here we're going to get 9 minus 8.23, enter, and then so here we're going to get 5.89 times 10 to the 0. But we have to have it to something, and it's going to be to this number here. and we've got to change the sign to the -9th. So this is our hydronium concentration. Okay, so this is going to be considered, based on the pH, a weak base. To check our work, we can then plug this hydronium concentration, because this is my hydronium concentration, we can plug that into the formula. Let's do so. Negative log of 5.89 e to the -9th, and we get 8.23, which is the pH I started with. So I know I've set it up right. So let's do the next one. pH of 2.54. The next whole number is 3. 3 minus 2.54. 3 minus 2.54 is equal to 0.46. Okay? Now we're going to take the inverse log of 0.46. So this is called my inverse log. And we get 2.88. Then we're going to write times 10 to the -3rd. It will always be a negative number. Okay? Because we're working with decimals. Okay, so this is my hydronium concentration. Again, you can check it. You can do the negative log of 2.54 and see if you get this number. So we know that 2.54 is going to be a strong acid. Last one, if the pH is 6.23, then the hydronium concentration is, so 7 minus 6.23, 7 minus 6.23 is 0.77, so the inverse log, is 0.77, so the inverse log, so 10 raised to the 0.77. And this time we're going to get the same number, 5.89 times 10 to the negative, but it's going to be 7 is my hydronium concentration, because that was my whole number. And a 6.23 is a weak acid. Please make sure you complete your worksheet number 1.